Yes, welcome back. Today we are going to solve another 3 problems under the topic steady state errors. So coming to the 25th question, if the damping coefficient is 0.65, then steady state error for the system shown below is. So they have given the block diagram and we have to find the steady state error. So by combining these two blocks, you will get the open loop transfer function for the given system, and then considering this unity feedback, you will get the closed loop transfer function. So find open loop transfer function which is given by this equation and closed loop transfer function which is given by this equation. So you have found out both of them. Now from the closed loop transfer function, if you compare with the second order or standard second order system, you can equate the coefficient of S and also the constant term, which is omega n square can be given as 4, and you know that psi is 0.65 and the coefficient of S is nothing but 2 omega n psi, which is 2 plus 4k. So by substituting psi as 0.65, you will arrive the value of k is 0.15. So substitute that k in the open loop transfer function, from which you will get this equation. So from this open loop transfer function, you can infer that the power of S is 1. So it is a type 1 system. So you have to calculate the KB, that is velocity error coefficient, because for type 1 system, you will get the finite error which is velocity error constant. So by applying the formula, KB is nothing but limit of S tends to 0, S into G of S. G of S is the open loop transfer function. So just substitute, you will get the value of KB, velocity error, as 1.54, and from this you will find the steady state error which is given by 1 by KB, which is nothing but 0.65. So the answer is 0.65. B is the correct option. So coming to the 27th question, you have to find the value of K for the given control system in the figure with 15% error in steady state. So they have given that the error is 15%. So from that you can calculate the steady state error is given as 0.15, which is nothing but 1 by KB, because here from the open loop transfer function, the value, that is the power of S is 1, right? So it is a type 1 system. So for type 1 system, the input must be a ramp input to get a finite error constant. So from the open loop transfer function, we know that n is equal to 1. It is a type 1 system. Hence input must be ramp input. Only ramp input yield the finite error in type 1 system. So we know that ESS is equal to 1 by KB equal to 0.15, because it is 15%. So from this, KB is 6.67, and you know that KB is nothing but limit S tends to 0, S into G of S. G of S is the open loop transfer function. Just substitute the open loop transfer function and equate S equal to 0. From this you will get the value of K is 40. So the answer is 40, D option. So coming to the next problem, from the unity feedback control system shown in the figure, the open loop transfer function G of S is given. The steady state error ES is due to the unit step input. So you have to find the steady state error. So for unit step input, so given R of S is 1 by S, because you are giving unit step input, right? So taking Laplace transform for R of t, you will get R of S is 1 by S, and it is given that G of S open loop transfer function 4 by S into S plus 2, and also the unity feedback. So hence H of S is 1. So from your equation, you know that error is given by R of S by 1 plus G of S. Just substitute the open loop transfer function. H of S will be 1. Okay. So by substituting this one, you will get the error signal E of S, and from this you are going to use the final value theorem and apply the formula. Limit S tends to 0, S into E of S will give you the steady state error, which is 0. So hence the answer is 0 here. So the option is A. That's all. Thank you.